do a camera with that, so we'll record. That way people who aren't here can just watch it.
That's amazing.
Say it again?
That's amazing.
Yes. I like it.
Is it recorded already? Yeah,
It is recorded, yeah, and I need to do it on YouTube. I can't post it to school. This little video will be posted to YouTube if you want to see it later. But we're looking at lecture 30, part B. Okay. And there's a little quick introduction to this section, because this is called log equations or exponential log equations, which means we're actually going to be solving for something. Okay, and we don't need computers. If you guys want to put computers away, we might have them out later. We'll see. But with the introduction to this, there are 4 situations. In part B, we're going to talk about 2 of them, number 1 and number 2. This is part B. And then if we get to lecture 30C, it'll be type 3 and 4. But the first one is we're going to be exponential equations. And they're going to have similar bases. So you remember the similar symbol from geometry, the little squiggly line means similar. So similar bases. And then the second one is also going to be exponential. And what do you suppose that's going to be? Non-similar or different bases. So non-similar bases.
The second one doesn't have a meaning?
It's exponential.
Oh.
The 2 little dots just mean ditto. Just I don't want to write exponential out again. And then number 3 and 4, we're going to cover those in part C, and I'll probably take a little break, and then if we have time today, we'll come back to part C. If not, we'll do it on Monday. But that's going to be, they're going to be logarithmic, or I'm just going to put logs. And remember, an equation has an equal sign, so logs on one side, oh, I better put this correct. Type 3 is going to be, yeah, logs on one side. So what do you suppose type 4 is going to be? Logs on both sides. So in a nutshell, that's what we're going to be covering. That's my objective. That's our essential questions. You will be solving exponential equations and logarithmic equations, all 4 types. Okay. Some of them are definitely easier than others. Some of them will take us right here. Logs on both sides will take us just very short time to learn. Some of them are a little more challenging. Okay. All right, we good? Page 2? Page 2. All right, type 1. A little brighter. Type 1. So we're looking at exponential with similar bases. Very simply, if you want a quick, how do we do this one, when it comes to similar bases, is you simply set the exponents equal. Then solve. That really is the one step. It's set the exponents equal, and then you solve that equation. Let's give you an example. Let's go with this one. 5, my base is 5 to the 2x equals 5 to the 8. The bases are identical, right? Both bases are 5. They're similar, they're the same. So then, if the bases are the same, for these to be equal, what has to be true? 2x has to equal 8. The exponents have to be equal to each other. So therefore, 2x must be equal to 8. So x equals 4. By the way, this is not necessarily one of the easy ones. This is going to get a little more challenging.
What does that say?
What's that?
Jesse?
Then solve. Set the exponents equal, then solve. So in this case, the bases are 5. You just 2x equals 8, x equals 4. You good? All right. Now we see how they get a little more difficult. Example. I give you 3 to the 2x plus 8 equals 81. So the first one, we look at this and say, well, they're not similar. 3 and 81 are not the same base. But can I write 81 as a power with a base of 3? 3 to what power is 81? I know someone knows it. Yell it out. 3 to the 9th would be much bigger than 81. 3 to the 6th would be much bigger than 81. 3 times 3 is? Nice and loud. Say
6
that.
and 3 is?
3 to the 4th. Very good. 3 times 3 is 9, times 3, 27, times 3 is 81. So I can rewrite this as 3 to the 2x plus 8 equals 3 to the 4th. And now, since the bases are now similar, they're the same, now you just set your exponents equal to each other. Therefore, by the way, 3 little dots just means therefore. Okay? If 3 to the 2x plus 8 equals 3 to the 4th, therefore the exponents must be equal. 2x plus 8 must be equal to 4. And then you solve your two-step equation. Subtract 8. So x has, say it again? Negative 2. So x must be equal to negative 2. Now there's your answer. So, we did our first example where they were already similar, exponents equal, you solve. This one is where one can be written as the other, okay? We can take 81 and write it with a base of 3. Okay, here's our third type. Example. 8 to the power of x equals 4 to the power of x plus 5. So can I write 8 as a power of 4? Or 4 as a power of 8? Terry, you with us? Can I do either one of those? 4 to the first is 4, 4 to the second is 16. So we can't do that. But can I write them both with the same base? What would that base be? Say again. 2. 8 is 2 to the third power. 4 is 2 to the second power. So I can rewrite this 8 as 2 to the third power to x equals, and 4 I can write as 2 to the second power of x plus 5. Now, going back to my exponential rules, if I have an exponent to an exponent, what do I do to those two? Multiply them. So I have 2 to the 3x equals 2 to the 2x plus 10. Because don't forget you have to distribute. And now, once again, we're back to our original part. You have both have a base of 2. Therefore, 3x must be equal to 2x plus 10. Solve, and we get x equals 10. And you can always go back with your calculator and check that if you want to. You simply do 8 to the 10th power equals 4 to the 15th power. I wouldn't do that without a calculator personally. Just me. But you can see if they check. Okay, type 1. Okay, I'm going to put 3 problems on the board. I want you to try them. Okay? 3 problems on the board. Try them. Let's see. Let's get rid of this color. Let's go to blue. Okay, so you try. Number 1. This is exactly like the first example I gave you. 7 to the 2x minus 3 equals 7 to the 19th. You might be able to get that done before I finish the second example. Number 2 is exactly like the second problem I gave you. 5, second example. 2x plus 1 equals 625. Number 3. 9 to the x minus 6 equals 27 to the 2x. We'll give you a couple minutes to try those problems. Question? Okay, first of all, 19 plus 3. And then how do you get rid of that 2? What happens with that 2? Can you turn off the light switch? Not the one closest to the door, the one closest to the ring in the room.
I have a question.
It's not that easier to see. Yeah.
Are we supposed to get a decimal for one of them?
Not 1 or 2.
Okay, that's, what about a fraction?
Yes, number 2 is actually a fraction.
Okay.
Yeah.
So we just circle that.
That's equal to 11. Yeah.
I've never been to public.
That just sort of took me aback when I saw it. Okay, see, it's a couple people still working, get another minute or two. Help me out though, 625 can be written as a power of 5.
Yes.
5 to what power?
5 to the 4.
5 to the 4. So I'm going to write this as 5.
So, for the last one, you just make,
This one here?
yeah, you just make 27, 9, no, 3 to the third power?
Mm-hmm. And 9 is
9 to the second.
correct. No, what was that?
X minus 6
Thank you.
equals 27.
Yeah, so if you didn't hear Terry, that's exactly what I'm gonna do. 9 is gonna become 3 squared to the x minus 6. And 27 is gonna become 3 cubed to the 2x. So what does this become? Power of what? 2x minus 12. And this side becomes 3 to the 6x. Therefore, 2x minus 12, 6x. Okay, so I showed you 1, 2, and 3. Any questions over those? Give me a scale of 1 to 5. Okay. Those are the numbers I'm saying 3s and 4s. Okay. So let's try this one then. Using the skills that you have, let's try a new problem. Let's try. Let me go to my notes. Let's try this one. 4x equals 10. This is kind of like that second example, right? Can you write 4 and 10 to a similar base? I heard a yes. What would it be? I can hear you. Okay, so 2 to the second. 2 to what power is 10? 2 times 5 is 10. 2 times 2 times 2 times 2 times 2 is 32. Can that be written to the same base? I see people shaking their heads. Yeah. No, absolutely not. This is type 2. So remember, it's going to be non-similar bases. Okay. What happens if I have a situation where I can't make them the same base? Or maybe it's like the second example I gave you, like 625, and you can't come up with 5 to the 4th. Okay. What do I do in that case? Okay. So type 2. There's actually steps here if you want the steps. We'll write them for you down real quick. Number 1. We want to take the log, and we haven't done that in class yet, so I'm going to teach something new. We're going to take the log of both sides. Just like you would add the same thing to both sides or subtract the same thing from both sides, we can take the log of both sides. Okay? And then we're going to use log properties to evaluate and solve. So this one, the trick is going to be, we're going to take the logarithm of both sides. Okay? That's going to give me the opportunity to use my rules, quotient identity, things like that, to solve. By the way, those of you in the back, what color is easiest to see? Doesn't matter. Are they all pretty clear?
Yeah, I can hear you.
They're all pretty clear. I think the lighter colors are a little more difficult to read on video, but someone will give me feedback there. So let's give you some examples here. Let's do that problem we just had. 4 to the x power equals 10. Okay? So remember, what I'm asking for is, what number can I take 4 to get me a whole number 10? So, I'm sorry?
Adding.
No.
No.
Adding what?
I was gonna say add 6 to get to.
Oh, unfortunately, you can't just add 6 because 4x plus 6 is just, you can't get mine. They have different exponents, different bases.
What are you asking?
I'm not asking anything. I was going to tell you how to do it. You will want calculators, by the way. Okay, if you don't have a calculator, have to have them. So, what I'm going to do is, this is the new step we haven't done before. We're going to take the logarithm of both sides. Okay? So we're going to do the log of 4 to the x power. I have issues with x's, by the way. 4 to the x power equals the log of 10. Now, by doing that, what rule allows me to take care of this x? Remember, with the x as the exponent, I can do what with it? I can move it to the front by using the power rule, okay? So I have x times the log of 4 equals the log of 10. Now remember, the log of the 4 is just a number you have on your, it's just a constant. You put your calculator, hit log of 4, it's going to give you a number. So it's just like saying 4x or 5x or 10x. So to get rid of it, I simply divide by the log of 4.
Wouldn't the 10 be 1?
It would be. So x is going to be the log base 10 of 10 is just going to be 1 by the identity rule divided by the log of 4. And you can leave your answer like that, or if it's a multiple choice test, they might be in decimal form. So let's go to decimal form real quick. Grab your calculators. Put in 1 divided by the log of 4, and let's see what we get. How do you do the log? Okay, great question. On these calculators, okay, log is right here by the 10 to the x power. So you're going to hit control and then 10 to the x. And it should say log. Now, on yours, these are the nicer ones. That gives you the base. You can put in the base. If there's nothing here, what's the base going to be? 10. Your calculator also knows that. So if you don't want to put in 10, if you just hit your right arrow and then put in 4, it should give you an answer. And what did you get for an answer?
1.6609.
There you go. 1.661. And of course, that is going to be rounded off and round off to 3 digits. That's kind of standard.
You said hold control.
Hit control and then 10 to the x power.
Yeah, it gives me something different.
Right here, let me see. And depending on what calculator you use, there are going to be different ways to put it in. Let me see it. Did you really, or you just don't want to come up here? Everybody else good with that?
Nope.
Nope, come here. Oh, don't forget it's divided by not times. So 1 divided by 8 log of. I'll leave it. And then you do 10. And then put it to the 4. Yep. Yep. Please don't ask me on a test, because when we come to a test, I can't help you. Good luck. So make sure you know how to do it on these calculators. All right. If we're good, let's try another example. 3 to the power 2x plus 3 minus 4 equals 17. Okay, so it wasn't part of the test. What do you suppose we should probably do first before we do the log of both sides?
Add something to
Say it again. Yeah, if we can get rid of that 4, that would be awesome. So if I add 4 to both sides, then I have 3 to the 2x plus 3 equals 21. Now we're going to take the log of both sides, okay? And then how can I rewrite that? so you're speaking awful kind of softly, and that thing is really loud. Can you speak up just a little more?
That's that putting the 2x plus 3 up there.
That's exactly right. 2x plus 3 out front. I would suggest you put it in parentheses so we make sure we keep it straight. Times the log of 3 equals the log of 21. Okay? Now what?
Divide both sides by log of
Exactly. All I'm going to do is just isolate the x. So let's divide both sides by log of 3. So I have 2x plus 3 is going to equal, what is the log of 21 divided by the log of 3?
7.
Is it? I don't think it's 7.
2 times. Oh, we gotta use the log.
Yeah, because remember, it's not just 21 divided by 3, it's the log of 21. What 10 to what power is 21? And 10 to what power is 3 to divide by those two numbers. So I got a decimal, what'd you guys get?
3. 0.771.
That's what I got. 2.77. And I hate to say this, but in every one of these, you will get some sort of decimal. Dealing with logs, you will get a decimal.
So how would you put this in a calculator? Like 21, and then 10 is 21?
I hit log to the base 10 of 21, and then divided by log to the base 10 of 3. You got it? Yes? You get it? You good? Okay. So then it's just a matter of solving our regular formula. Add 3, divide by 2. So 2x equals 2.771 minus 3, because you subtract 3 from both sides. So we have 2x equals negative 0.229 divided by 2. One, 4.3. So, and you're going to get a really ugly decimal. All right, normally I would be done, but I have to show you one other thing because when you get to delta math, you might see this, okay? The process is going to be the same, but there's going to be one little change if you see a letter. Last example. Let's say you see something like e to the 8x equals 5. Something like that. Okay, have we talked much about the letter E? We did mention it once. So when you come to calculus, you'll find out that the limit, I believe, as x approaches 0 of 1 plus 1 over x to the x power equals the letter E, which is about 2.71828. It's like pi goes on forever. It's the rate for constant growth. When we do some actual examples of this, it'll be like population or something with continuous growth. Okay? So that's what we call the natural log. It's the base of the natural log. So when you see E, rather than doing the log of E, you're going to do the natural log of E to the 8x equals the natural log of 5. Now, if you look at your calculator, you should see a button on your calculator that says E to the x, and above it it'll say ln of x, I believe. Is that how these calculators work?
Yeah.
Okay? So very simply, you'll hit ln rather than log. Everything else is the same. Okay? You bring out the 8x. The natural log of E equals the natural log of 5. Now, I told you the base of a natural log is E, right? So if the base is E and the argument is E, what is the natural log of E? Okay, so we had this the other day. We had, actually, I think Shayla mentioned earlier, log to the base 10 of 10. When the base and the argument are the same, what's the answer? 1. So if I have the natural log, which has a base of E to the E, that's going to be equal to 1. So it's actually kind of nice when you have this, because it's just 8x equals the natural log of 5. Because the natural log has a base of E. Divide by 8, and you get your answer. The natural log of 5 divided by 8. So whenever you see E, just take the natural log rather than the common log. Solve it the same way.